Okay, so we're back in order here. So as you can see here, the standard deviations for the two portfolios are 367.42 and 2,573.42. Just as we discussed with regard to data back in Chapter 3, the units of the standard deviation are the same as the units of the random variable, so both of these amounts are in dollars. Now, there's that general concept of variance, but here we're talking with a portfolio, we're talking about risk. And one thing to know about risk is that a lot of times people think of risk as something that is inherently bad. Risk is basically a measure of variability. So when you have a higher level of risk, while that means that in a lot of cases when you talk about a portfolio or you talk about an investment, something with a higher risk usually implies that you have the possibility of making a lot more money, but you also have the possibility of making a lot less money. Something that has effectively zero risk would be something along the lines of a savings account or a certificate of deposit. Those are supposed to be zero risk, assuming that the Federal Deposit Insurance Corporation is able to come through. If they're not able to come through on our savings accounts, then we've got a lot bigger worries than the variance of a discrete random variable. Anyway, so here's another example that I've given you, and what we've got here, for those of you who are business majors and are looking at having to take operations management, this is a simplified inventory problem. What we've got here is, if you looking at a local convenience store that sells the local newspaper, and the issue for them is at the end of the day, in most cases, they're not going to be able to sell the papers the next day, or certainly not far after that, unless something big happened, because it's old news at that point. So what they're looking at here is the number of copies that go unsold at the end of the day. We've got our values of X, so this is anywhere between 0 and 5 copies, and their corresponding probabilities. So first here, looking to find the mean, the variance, and the standard deviation. We've gone through these formulas again. So in this case, the value of the mean is 1.25. Trying to look through this little screen here. If you follow along with the formula for the variance, it works out to be 1.7175. Remember, again, the units there are squared, so we really want to go look at the standard deviation. The square root of that is a little bit over 1.31. So the standard deviation here is approximately 1.31 unsold copies. Now, just as a little reminder, something that came up earlier with regard to Chebyshev's rule, this certainly is not normally distributed, but you'll see questions like this in homework where it asks to find the probability that X falls within one standard deviation of its mean, and also to do this for two standard deviations. So in the first case, right here, we're looking for the probability that X is between mu minus sigma and mu plus sigma. If you go ahead and substitute the values in there, what we end up getting is that X is between negative 0.061 and 2.561. Since X is an integer, we're looking at the number of unsold copies. This is effectively the same as X is between 0 and 2 inclusive. You add up those probabilities and you get 0.81. Okay, we repeat the procedure for two standard deviations. So in this case, X is between negative 1.372 and 3.872. So again, in order to be between those and be an integer, that's anywhere between 0 and 3. We add up those probabilities, and that gets us up to 0.92. Okay, that is the end of the material from section 7.4. We're now moving on to section 7.3, which is continuous random variables. We'll also follow that up with section 7.6.